All right, this video covers page 9 in your lecture note packet. It begins chapter 2, discussing the average rate of change in linear functions. Average rate of change measures how fast the output variable y changes on average as the input variable x changes. Up to this point, we've been talking about functions. Functions have input, functions have output, and we know for a function, each input has exactly one output. So if we have y equals f of x, that means y is a function of x, and x is the input variable, y is the output variable. Average rate of change, again, measures how fast the output variable y changes on average as the input variable x changes. So calculating the average rate of change is very similar to calculating, is identical to calculating the slope of a straight line. Here I have the graph of a arbitrary straight line, 2 points labeled on it, x1, y1, x2, y2, right? The straight line goes through those 2 points. And from your high school algebra, you may recall that to calculate the slope of this line, you calculate the rise and the run. And the slope is rise over run. The rise is the difference in the y coordinates, and the run is the difference in the x coordinates. And over here in our formula, we have average rate of change is rise over run, which is the difference in the y coordinates divided by the difference in the x coordinates, and which is identical to calculating the slope of that straight line. Okay? So we're going to apply this concept of average rate of change in the example down below. A football player runs for 1,056 yards in 2006 and for 978 yards in 2010. Find the average rate of change in his performance from 2006 to 2010. Round to 1 decimal place and state the units. Then write a sentence interpreting what his rate of change means. Well, the input variable, right, is the year, and the output variable y is the yards. In 2006, he ran for 1,056 yards. In 2010, he ran for 978 yards. So 1 point can be written as 2006, 1056. 2006 is the input, 1056 is the output, and then the other point can be written as 2010, 978. Remember, the first number is x, the second number is y. So the average rate of change, which is a difference in the y coordinates divided by the difference in the x coordinates, is 1056 minus 978 divided by 2006 minus 210. Well, that simplifies to 78 over minus 4, which is equal to minus 19.5. So the average rate of change is equal to minus 19.5, and the units, right, from up above is units of y divided by units of x. Well, the units of y are yards, the units of x are years, and so his average rate of change was minus 19.5 yards per year. So in a sentence, we can write the number of yards ran decreased because the average rate of change is negative. The number of yards ran decreased on average by 19.5 yards per year between the years 2006 and 2010. So calculating the average rate of change in this example is just like calculating the slope of a straight line.